Now, I'm sure you have this question. What the peep is multiprocessing? Why do we need multiprocessing? I'm going to answer all those questions right here. But before we get started, if you're new to the channel, please subscribe, like the vid, guys. Take a deep breath and let's get started. Multiprocessing refers to the ability of a system to support more than one processor at the same time. This results for application in a multiprocessing system to be broken down into smaller routines and to run independently. And this makes the job of the operating system to allocate these threads to the processor, which improves the performance of the system. Now, look, I hope you're still with me because we need to answer one more question before we dive into some code and actually see what multiprocessing is like in Python. The second question is why multiprocessing? Why do we need to do it? Now, I want you to consider a computer system with a single processor. And then something very normal and usual happens. This system is assigned several processors at the same time. Now, let me just rewind myself a little bit. A single processor gets assigned several processes at the same time. And we know this is going to be a disaster because it will have to interrupt each task and switch briefly to another to keep all the processes going. You know what? Let me take you briefly to a chef's kitchen. And this chef right here is working alone. He's a loner. He has nobody with him. What happens is that this chef will have to do several tasks like baking, stirring, kneading the dough, and so much more. He's going to have to do all that by himself. So I hope you're getting the gist right now. The more tasks you have to do at once, the more difficult it gets to keep track of all of them. And keeping the timing right becomes a challenge. It becomes a catastrophe. It becomes a disaster. And here is where multiprocessing comes to the aid. Multiprocessing systems can have one, a multiprocessor, which is a computer which has more than one central processor, or they can also have a multi-core processor, which is a single computing component with two or more independent actual processing units called cores. Here, the CPU can easily execute several tasks at once, with each task using its own processor. Because this is exactly what happens when the chef gets assisted by an assistant. So he can divide the task among themselves, and the chef doesn't need to switch between tasks. So hopefully you understand it. But now let's get to some code and let's type some code right now. Okay, so we can see our code right here. And the first thing we need to do, for sure, I already put some boilerplate so we know what to do. And for sure, we have the comments too, so we know where we're going. You need to have a destination. Imagine going on a trip and you don't know where you're going to. Well, then there is no trip. So you know what? Let's get started. First thing we need to do is we need to import the module. So we'll say import multi-processing. Now, after we've done that, what we need to do next is we need to create a function to print the cube of a given number. And the way we do that is we'll say print. I'll first say cube, curly brackets right here. Now we'll say dot format. I would say num multiplied by num multiplied by num. So that's how you get the cube 3 times. I'm just going to copy this right here because we want to do the same, but this time we want to get square. I'll change this from cube to square, and we take one num out because square is just 2. Now that we've done that, we need to create our processes. So the way we create our processes, we'll say, in this case, we'll say P1 is equal to multiprocessing dot processes, and then we'll set a target, set that equal to print underscore square, and we'll also give it an args. I will set the args to 10. Just gonna copy this and we do this something very similar, but we'll do it for P2. And we're putting cube. We're not calling it, we're referring to it. So that's why we remove the 2 brackets there. Finally, what we can do is we can actually start it and we say P1 dot start. And we can say P2 dot start. But what we need to do next is that we need to wait until the process 1 is finished, and then we do the same thing for process 2 too. And the way we do that, we'll say P1 dot join, and after that we'll say P2 dot join. And finally we just print done. Okay, but before we run it, I just saw we have a bug right here. This should be capital P, and also right here, capital P. And now let's run it. You can see right here we get a cube. The cube is 1000. The square is 100. We change this to 25. Or here to 25 also. I'll run it. You see we get 625 and 15,625. So we see it's working out well. Now let me explain this code right here. Okay guys, let me explain this code because we need to understand everything we just wrote right here. The first thing we did is that we imported the multiprocessing module. The next thing we did is we actually created a process. We created an object of process class and it takes the following arguments. The first argument is target, and target is the function to be executed by process. And then we also have args, and args is the arguments to be passed to the target function. Okay guys, I want you to quickly know that this process constructor takes many other arguments and we'll discuss this later, but for this example right here, we created two processes with different target functions. Finally, we get to the point where we actually can start the process or we can start a process and we use the start method of the process class. And in order to stop the execution of a current program until the process is completed, we use the join method. As a result of this, the current program will first wait for the completion of P1 and then P2. Once they are completed, the next statement of the current program are executed. Yeah, hopefully you guys enjoyed this tutorial. If you did, please leave a like, subscribe to the channel, and I'll catch you guys on the next one.